This question relates to the stability of geminal diols. A geminal substitution means two similar groups are substituted on the same carbon atom. For example, this is known as geminal dichloride. This is known as geminal dihydroxy compound. Geminal substitution means there are other groups also there, but the same group is substituted on the same carbon atom, the same two groups, twice they are substituted. Double substitution or geminal substitution. This type of substitution is known as geminal dihydroxy substitution. This is referred as geminal dichloro substitution. Geminal dichloro compounds are known. Methylene dichloride is a very good, very stable compound, whereas geminal dihydroxy compounds are generally very unstable. Immediately it loses a molecule of water to give rise to an aldehyde or something else. So this type of compounds will be formed. That is usually the case. The interesting part of this question is generally geminal dihydroxy compounds or geminal diols it is given. Geminal diol. Diols means two alcoholic groups. Two alcoholic groups present on the same carbon atom, they are unstable. But in the case of the chloral hydrate, this is actually chloral. What is trichloral? Chloral is trichloroacetaldehyde. This is all the three are hydrogen. It is known as acetaldehyde. This is known as chloral or trichloroacetaldehyde. Trichloroacetaldehyde exists in the form of a hydrate in a very stable form. Or in other words, it is like this. Three chlorine atoms are present, which is connected to the carbon, and this hydrogen will have this. It will be like this. So strictly expecting that the geminal diol is not stable, this compound should not also be stable. But actually, very interesting part of this compound is, interesting aspect of this compound is very stable in spite of the fact it is a geminal diol. How do you explain this phenomenon? It is very easily explained because it is these two hydroxy groups, we can write it in a slightly different way. We can make it as one, this hydroxy group can be, it's of course bent, and then this is very stable because of two very important reasons. One is the three chlorine atoms are there in the adjacent carbon atom. Normally in acetaldehyde there are three hydrogen atoms, but in trichloroacetaldehyde there are three hydrogen atoms in the adjacent carbon atom. Therefore, they are, by powerful electron withdrawing effect, they draw the electrons. That is one very important point. Because of the powerful electron withdrawing effect of the three chlorine atoms, the stabilization is affected. In addition to this, there is also another very important factor, a hydrogen bond. What is meant by a hydrogen bond? A hydrogen bond is one in which hydrogen atoms, it has not been clearly written, hydrogen atom. A hydrogen atom remains between two electronegative atoms. This hydrogen is between oxygen and this chlorine. Of course, the position, the distances are not properly explained because of the distance of this, but this is actually the case. Here also we have a hydrogen, and then hydrogen exists between oxygen and chlorine. This hydrogen is linked between hydrogen and chlorine. When you look at the structure very carefully, you will find there is a regular covalent bond, this oxygen and hydrogen. This is only a single bond. There is a regular covalent bond between this oxygen and hydrogen, and similarly there is also a regular covalent bond between this hydrogen and oxygen. But this bond is only a van der Waals force. That is a typical of a hydrogen bond. A hydrogen bond is one in which the hydrogen is actually sandwiched between the two electronegative atoms, where there is a regular chemical bond or a covalent bond exists, and the other bond is only a weak van der Waals forces. This is only a very weak van der Waals forces. Of course, the hydrogen bond will be strongest when the two electronegative elements, electronegativity of the two elements are very strong. This is not a very strong hydrogen bond. Reason being, chlorine generally does not participate very often in hydrogen bonding, even though chlorine is an electronegative element, but there is a little bit of participation of this chlorine and oxygen in the hydrogen bonding, and because of the two reasons, powerful electronegativity and electron withdrawing effect of the three combined cumulative effect of the three chlorine atoms due to this attached to this carbon atom, the neighboring carbon atom, and also due to the hydrogen bond that is formed in this way, this chloral hydrate or trichloroacetaldehyde water molecule becomes a very stable species. Generally, Geminal dihydroxy compounds are never stable and they decompose immediately, losing a molecule of water, giving rise to a free aldehyde.